Okay, guys, so we are starting where we left off. We are trying to finish this problem, and the next thing that I notice here is that there is a common factor. I have a 3 here, and I have a 3 here. And what I would like to actually do, now it's going to let me change colors, great. I would actually like to factor out a -3. And I do this because I have a negative out front. That first term is negative. So I'm going to factor out that -3, and that would leave me with a y minus x dy over dx. Then my denominator will stay the same. I'm not changing that any whatsoever. All right, now here's the problem. I have my second derivative, but I don't have it in terms of x and y solely. Only I have right here, I have a dy over dx. So I need to get rid of that. I need only terms of x and y. I do not want to see that dy over dx. So what I'm going to do, if I can zoom out, what I'm going to do is go up here where I have dy over dx is equal to that, I'm going to actually substitute into that equation what we found dy over dx to be. So that's going to give us a new expression. It's going to be -3, open parentheses, y minus x times, and what I'm going to do is now multiply it times that term we had up earlier, that expression, y minus 2x divided by 2y minus x. And remember, all of that is still divided by 2y minus x all squared. Now from here, guys, it is algebra still, just still algebra. And I'm not saying that lightly. I'm saying that because you have to pay attention to your rules, guys. What I would do next is um, distribute that x to that rational expression. And remember, when I multiply that x times that rational expression, I'm only going to multiply in that numerator. You're not going to factor through and multiply in that denominator. So that's going to give me, I'm going to leave that -3 there. That's going to leave me with y minus, that's going to give me xy minus 2x squared all over 2y minus x, and I'm going to leave my denominator the same, 2y minus x all squared. Now, when I got to this point, I like to cross multiply to add my fractions. And when I say cross multiply, I mean I like and I visualize it. But guys, you might want to rewrite this as a y over 1. What I do is I rewrite that y as a fraction, as a rational expression, and then I like to combine those fractions. That's going to give me, and you guys hang with me, I multiply this way first, y times 2y minus x. That would give me 2y squared minus xy. Then that's going to be minus, and then, and the reason I did minus is because that was a minus sign there. And then I'm going to multiply this way. And because that's xy minus 2x squared times 1, nothing's going to change. But because I have a minus sign there, I am going to put that entire expression inside of parentheses. And then your denominator you will get by multiplying these two denominators together. And this is a nice problem because I have 2y minus x times 1. So that just leaves me with 2y minus x. And then we have to remember that it's going to be all over 2y minus x all squared. Now, I jumped in my notes when I worked this out, and I kind of combined these two terms together, but I want to make sure you guys understand why. this is going to be, this is the same thing as 2y squared minus xy. Well, let's combine my terms. I was not paying attention. Let's combine our terms, and that way I will have less to worry about later on. What I notice here is that I have a negative xy minus xy. That's going to leave me with a negative 2xy. And then I have a minus here and a minus there. That this minus will change the sign of that negative there in front of that 2x squared. So that will become a plus 2x squared all over 2y minus x. And I really have, that's really my numerator, and I have all over 2y minus x all squared. You guys, is it not true that a fraction is really just division? So what I could do is rewrite this sign as a division sign. Remember, when we divide fractions, imagine I have a fraction in my numerator or my denominator. What happens when I divide fractions? Keep your numerator the same. You change that fraction bar to a divide sign, or good gracious, change that fraction bar to a multiplication sign. And then you're going to flip that second fraction there. So that's going to be 1 over 2y minus x all squared. So again, there's a rule that I know in high school when you learn this, some teachers say keep, change, flip. So we keep the numerator the same. We change our division to multiplication, and then we flip that bottom fraction. And what happens is we now have 2y squared minus 2xy plus 2x squared all over 2y minus x all cubed. Now, I could jump that step because I would know here, I'll go back. I'm sorry if I'm moving too fast. But I knew here that these would just combine, and that would give me a 2y minus x cubed. But you have to understand why. Why does that happen? How does that work? And there's a few different ways you can show it, but this right here is the way I see it and that I understand it. And that's how we got to this point here. And I think, if I am not mistaken, that I forgot something here, guys. I did. Let's back up. We have to remember, and this is good because you can see where if I was in class, this is hopefully a spot that you would catch and you would see that I just left my 3 off. But that 3 belongs out front. But guys, what I was doing here is I was trying to simplify that numerator. So now if I bring this 3 back, I have what's inside of those parentheses simplified. What I have now is a 3 out front. So it's going to actually a negative 3 if I remember correctly. Let me go back. That was a negative 3. So I actually have a negative 3 times all of that I simplified and combined. And what I noticed in my right now is that I still can simplify this a bit more. I have a 2, and a 2 there. And what I can do is I can factor out that 2. And when I factor out that 2, that's going to actually become a negative 3 times 2 on the outside. And I'm not going to write that like that. I'm actually put negative 6. And that will leave me with y squared minus xy plus x squared divided by 2y minus x all cubed. That's not a pretty y. Let's make it look neater, guys. But that is it. And I checked my math lab. I put it in because sometimes they are picky about the way they want their answers. But that's it. So this is implicit differentiation, if you can follow what I did here, these rules will be the same. They remain the same every time you do a problem like this. So again, if you have questions, feel free to shoot me an email. I will be happy to help you.